Before I can explain RFLP to you, I have to explain gel electrophoresis. This is a technique used to separate DNA by length. It can apply to other biological molecules like RNA or protein, but I'm going to only explain it for DNA. Essentially, smaller fragments of DNA are able to move through the gel faster. The DNA is pushed by an electrical current, and because DNA is negatively charged, electricity can force the DNA fragments through the gel. And you'll end up with a picture like this. Bigger fragments are at the top of the picture because they move slower through the gel, and little fragments are at the bottom of the picture. RFLP stands for Restriction Fragment Length Polymorphism. Like many molecular genetic techniques, it begins with PCR, and it's used to find SNPs and indels. How does RFLP work? Like I said, it begins with PCR, and let's say those are the strands of DNA amplified by the PCR reaction. Notice that I've highlighted the SNP in blue. Restriction enzymes are added to the PCR product. Restriction enzymes are from bacteria. In this example, I'm using EcoR1, which is from the E. coli bacteria, and it's restriction enzyme 1. Restriction enzymes only cut at palindromic sites. A palindrome is something that reads the same forward or backward. So now I thought I'd give you some common examples of palindromes in regular English. So one example is race car. You can see that forward and backward, it's the same. Another, if you ignore punctuation, is Madam, I'm Adam. And my favorite palindrome is Doc note, I dissent. A fast never prevents a fatness. I diet on cod. Okay, so back to RFLP. I was saying that restriction enzymes only cut at specific palindromic sites. In this case, notice the top piece of DNA reads GAATTC, and its complement, when read backwards, reads GAATTC. This is what I mean by a palindromic site. Also, notice that in the bottom piece of DNA, the SNP prevents the enzyme from cutting it. This is because of the specificity of restriction enzymes. Now I'm going to give the PCR product and the fragment's lengths to make the rest of the example easier. Let's say that the PCR product is 87 base pairs long, and the fragmented DNA is 55 and 32 base pairs long. These fragments will be separated using gel electrophoresis, and the gel might look something like this. At the far right of the gel, highlighted in red, is the DNA ladder. This is like a ruler for gels, and it works because you know the length of each band. This is a 25 base pair ladder, so the band closest to the bottom is 25 base pairs. Going up the ladder, you see 50 base pairs and 75 base pairs before the bands of the ladder blur together. A person homozygous for the C SNP would have only one band, the two uncut PCR products. And it's closer to the top because it's a long strand of DNA. A person homozygous for the A SNP will have two bands, the 55 base pair band and the 32 base pair band. And the heterozygous person will have all three bands.